Hello students, welcome to our student support program grade 11 additional mathematics. Today in integration you are going to learn how to evaluate definite integrals. So let's begin. In previous videos you have learned about indefinite integrals such as the integration of x to the power of 3 with respect to x is equal to 1 over 4 x to the power of 4 plus c, where c is an arbitrary constant. This is called an indefinite integral. Why do we call it indefinite integral? Because it has infinitely many solutions. Now, let's have a look at definite integration. You can integrate a function between two defined limits. The integral of a function x to the power of 3 with respect to x between the limits x is equal to 2 and x is equal to 5 is written as follows, where x to the power of 3 is the function, 2 is the lower limit, and 5 the upper limit. So let's integrate this function. First, we are going to integrate x to the power of 3 to obtain 1 over 4 x to the power of 4 between the limits 2 and 5. Now we are going to substitute the limits by starting with the upper limit first and then subtract by substituting with the lower limit to obtain 1 over 4 5 to the power of 4 minus 1 over 4 2 to the power of 4. Evaluating this, we get 152 1 over 4. In general, the evaluation of a definite integral can be written as follows. The integral of a function f of x with respect to x between the limits x is equal to a and x is equal to b is, let the integration of small letter f of x be capital letter F of x, written as follows between the limits a and b, which is equal to f of b minus f of a. Some rules for definite integrals. Integration of k f of x with respect to x between the limits a and b is equal to k multiplied by integration of f of x with respect to x between a and b. The integration of f of x plus or minus g of x with respect to x between the limits a and b is equal to integration of f of x with respect to x between the limits a and b plus minus integration of g of x with respect to x between the limits a and b. Let's apply these rules to some examples. Evaluate integration of x squared plus 3x minus 5 with respect to x between the limits 1 to 3. Which is equal to, first we are going to integrate the function to obtain x to the power of 3 over 3 plus 3x to the power of 2 over 2 minus 5x between the limits 1 and 3. Substituting the limits starting with the upper limit first, we get 3 to the power of 3 over 3 plus 3 multiplied by 3 to the power of 2 over 2 minus 5 times 3 minus, now we substitute the lower limit, 1 to the power of 3 over 3 plus 3 multiplied by 1 to the power of 2 over 2 minus 5 multiplied by 1. Evaluating this, we get 10 and 2/3. Example 2. Evaluate integration of square root of 2x minus 3 with respect to x between the limits 1.5 to 7. First, we are going to rewrite the function as follows. Integration of 2x minus 3 to the power of half with respect to x between the limits 1.5 to 7. Integrating the function, we get 2x minus 3 to the power of 3 over 2 divided by the power 3 over 2 multiplied by 2, where 2 is the differentiation of the bracket between the limit 1.5 and 7. Simplifying this, we get 2x minus 3 to the power of 3 over 2 over 3 between the limits 1.5 to 7. Now, let's substitute our limits, starting with the upper limit first. 2 into 7 minus 3 to the power of 3 over 2 divided by 3 minus 2 into 1.5 minus 3 to the power of 3 over 2 over 3. Evaluating this correct to three significant figures, we get 12.2. Example 3. Evaluate e to the power of 2x minus 1 with respect to x between the limits 1 and 3. Integrating the function, we get e to the power of 2x minus 1 divided by 2, where 2 is the differentiation of the power between the limit 1 and 3. Now, let's substitute the limits. E to the power of 2 into 3 minus 1 divided by 2 minus e to the power of 2 into 1 minus 1 divided by 2. Evaluating this, we get 72.8. Example 4. Find the exact value of integration of 2 cos 3x minus 6 with respect to x between the limits 0 to pi by 3. First, let's integrate the function. 2 sine 3x divided by 3, 3 is the differentiation of an angle, minus 6x between the limit 0 to pi by 3. Substituting the limits, we get 2 sine 3 multiplied by pi by 3 over 3 minus 6 multiplied by pi by 3 minus 2 sine 3 multiplied by 0 divided by 3 minus 6 multiplied by 0. Evaluating this, we get negative 2 pi. Example 5. Find the exact value of integration 3 over 2x minus 7 with respect to x from the limits 2 to 6. Note, when integrating this function, we include the modular sign when finding the definite integrals. Integration of the function will give us 3 ln modulus of 2x minus 7 over 2, where 2 is the differentiation of 2x minus 7 between the limits 2 to 6. Substituting the limits, we get 3 ln modulus of 2 multiplied by 6 minus 7 over 2 minus 3 ln modulus of 2 multiplied by 2 minus 7 over 2. Simplifying, we get 3 ln modulus of 5 over 2 minus 3 ln modulus of minus 3 over 2. Note that modulus of a negative number is 3. We obtain 3 over 2 ln 5 minus 3 over 2 ln 3, which is equal to 3 over 2 into ln 5 minus ln 3. Using log law, it can be further simplified as 3 over 2 ln 5 over 3. Now that we have done some examples for you, here are some exercises for you to practice. So students, today you have learned how to evaluate definite integrals. I hope you have enjoyed it. See you next time.